Hello, what's up, guys? Welcome back to Tutoring with Abdul. In today's lecture, we'll be talking about um logic gates, what logic gates are, and where they where are they used. We'll cover briefly AND gate in this lecture, and after that, we'll be covering each gate by uh, each lecture. So today we'll discuss the gates in general and cover up AND gate. So let's go on and talk about the logic gates. So everything in the world has building blocks. For the digital electronics, the building blocks are the logic gates actually. So the logic gates. In the previous time, people were thinking like the computers, calculators, and other discipline devices. They were looked at it like as a magical devices, but actually they are pretty much very logical in the terms of how they're used to and how they're designed. So that's how we call these things are the basic building blocks of a digital electronics are called logic gates. So there are logic gates, different types of logic gates, like we will say the TTL, TTL, and CMOS. Logic gates can be constructed using diodes, relays, and switches. They can be constructed using these components. We will say like there is logic function. What logic function is? Logic function is a task performed by logic gate is a called logic function. A task performed by a logic gate is called a task performed by a logic gate is a logic function. But what the logic function can be implemented by hardware. So these are the hardware part of it, or by a programming devices such as microcontrollers or PLCs. So the logic function can be hardware like relays, switches. In the old days, we used to do relay logic. Relay logic. That was old days when we did not have computers, or we had barely some computers. And today we have a programmable. That's our programmable or programming devices. Such as microcontroller and PLCs. So programming devices, PLCs and microcontrollers. Controllers. So this is the software side, and this software can control the logics of motors or anything is used in a field or a plant, conveyor system, anything. So just to review this thing, we said logic gates. Logic gates is a basic building blocks of a digital electronics. We have a various logic. We can make logic gates, using switches, diodes, relays, and everything. There are famous kind of logic gates, but the common one are TTL and CMOS. We'll talk about them later. Talking about logic function, a test performed by a logic gate is called logic function. So in the old days we had a hardware type of logic function and like relay logic. In the modern day we are using programming devices such as PLCs, microcontrollers, and everything like that control the logic of a system. There are a variety of logic gates, TTL and CMOS, as we said. We will talk about them later. These things, hopefully, in some lectures coming in. In this lecture, we will briefly talk about AND gate. This guy, we will talk about that, and we'll see what that is. So let's move on. AND gate. AND gate. This is the one of the logic gates. It's very common for safety devices, for safety operation of a circuit. There's another name for that. It's all or nothing. That means if you have to have an output for that one, you should have every input on or binary one or high on a voltage side, and in order to get an output high. So it's also called all or nothing gate, and that will be AND gate. So that's the first gate we will discuss. I say like it's commonly used in a safety operation, and I put an example of practical example like car starting. When you do start your car, modern day cars, if you have a push button to start or you have a key starter, if you have a push button for that, because it's subject to have a safety issue in case if you have a kid in there or somebody mistakenly hit the wrong button. So they added a logic in there. They added, for example, this switch, which is your, for example, this is your brake, and then your push button is right here, and this will be your car start relay. It will start your relay. So you have to hit the brake and then push that button. It will work, it will complete the circuit. So this relay will energize and will start your car. But only if you hit this button, for instance, it will start some components of your vehicle. Like for example, you will only get that radio and stuff will turn on, but not the engine will not come on. So that's how we use that AND, because you have to have this one and this one to get your machine or your motor running, which is in this case is your car. Hopefully this is clear, because you have to have this one and this one to get that control relay or a car start relay on. Okay, so we put another example here for the AND gate. AND is known for all or nothing, or it's a gate that you need to have all the inputs high in order to have an output high. If any of your input is low, your output will be low. You have to have every input high to have a output high or output turn on. Okay, let's pretend it doesn't spell like that. It will be pretend. Let's work on some spelling. Pretend. It's much better. A circuit where we have a lamp, I hope lamp spells right, and two switches in the following figure. So we have 12-volt DC circuit there. We have one switch here, one switch there, switch 1, switch 2. We have a lamp right here. In order to light that lamp up, we have to have this button pressed and this button pressed, because these two, both of them should be pressed in order to light up this lamp. Otherwise, if you press switch 1, it will not complete the circuit. The circuit will stop right here, so it will not flow all the way back to the negative terminal of the battery. So in order to have a complete circuit, you should have all the switches closed. It should go through the light and make it back to the battery terminal, or any power supply, anything is there, that terminal should be completing your circuit. So for that, light to be turned on, you have to have this one on and this one on. So this is this one, and that switch should be on to turn on this light. So that's how practical example of the light is here. So I said, like, how will this this lamp light up? Yes, you have to press this switch and that switch, both on. If they're both on, this light should be on. So there we go. Now for symbol of this logic gate, and symbol for AND gate is this guy right here. This is your symbol. To the left side is your inputs, input 1, input 2. To the right side is your output. This is your output, and this is your input side. So in this little gate, you see, like, you have two inputs going in and one output is coming back out there. So this should be, the input number 1 should be on and input number 2 should be on in order to get output number 3 on. Or for in this case, you have to have switch 1 and switch 2 on to get your lamp on. Okay, so it's explained here where 1 and 2 are inputs and 3 is an output. Okay, the term logic is used to refer to decision-making process, which is clear, which makes sense. The logic is used to refer to decision-making process, but logic gate is a circuit that has the ability to decide whether to say yes or no based on the input condition. So the logic is the decision-making process. Yes, so this is the whole thing is the decision-making process. But the logic gates has the ability to say yes or no. So this is your gate, this is AND gate. It will be depending on your inputs. If your inputs are high in AND gates, your output will decide, yes, I will have a high output. If it's one of them is low, your output will be deciding low. I'm low, because AND gate to be, you have to have everything from the input side to have an output on or high. Your input should be high to get your output high. That is one other way to define your AND gate. So the logic is a term that is used for decision making process, but the gates or logic gates is a circuit that has the ability to say that, hey, I can make it high or low as an output depending on your input status there. Okay, so now let's go and talk about actual example of AND gate. We will depict that AND gate here. So we have switch A or switch A and switch B going into AND gate, and we have a LED connected after that AND gate, connecting to a resistor. We will just say like unknown resistor, like let's say 50 ohm. For example, I'm just naming it 50 ohm. Okay, I don't like that writing, so let me clear that. So that will be 50 ohms. So there are two switches or two input coming into this AND gate, going through a LED. LED mean light emitting diode. Going through that, and that's going through a resistor, and that's finally going to a ground. So doing that, we will complete our circuit. But this gate will not be satisfied if your one of these input is low. For that to be actually true, you have to have input A and input B both high to get your output high. For that to make complete circuit, it has to go all the way to this ground. And if these A and B are on, the LED, that red LED will light up. So the explanation for that is, condition for this LED to be lit up are input A is on or H is high or binary 1. So you can say 1 on, binary 1. Input B is on or 1. If they're both on, your output should be on. That will become 1, and that will flow that current through this circuit, through this resistor, and will make a complete circuit to the ground, and this LED will be on. If these two inputs are high, the output is 1 or high. So If this is on, yes, again this output will be high and will complete the circuit and LED will lit up. Now we have since we have two inputs, we have a many possible solution, like, okay, so how can we design the circuit and where is our table stands? So to put all these possible input combination in a table that can be read easily, we will call that a truth table. The truth table is, it will discuss the whole every possible combination of every possibility of the inputs that can happen in the circuit. We call that as a truth table. So we said input 1 and input A and input B that are there, and there is a light there and a light, and I also said like output, that should be the same. If your input A is 0 or low, they're same, or 0 or L, you can say L also. Okay, so or L. If input A is 0 and input B is 0, your light will not come on. So that means if this switch is off and A switch is off and B switch is off, your output will be off. So that means your light will be off. Now condition number 2, if your input A is 0 or low and input B is 1, your light will be still off, because it's AND gate that requires all the inputs to be high in order to get an output high. So in that case it will be still 0, or the light will be off. Third scenario is if your input A is on or high or 1, binary 1, and input B is 0 or low, your output or light will be off and output will be still binary 0 or off. The last case and the only case for the AND gate in this condition with two inputs, your input A is high and input B is high, so you'll get your light on and your output will be high or on. So conclusion for that circuit will be, for the light to light up, is the only condition is satisfying when both inputs are high. That's very satisfying there, because both the inputs should be high to make your output high. That is one of the most very common statement of the AND gate. So now moving on, how we said this thing in English, we have two input coming into that AND gate and one is going out. In English we say that input A is ANDed with input B to get output C. So we say it again, input A is ANDed with input B to get output C, or input B is ANDed with input A to get an output of C. That's English way. So now there's a term that we said, like, we do know what algebra is, but in this case we have a Boolean algebra. We do deal with the Boolean algebra or Boolean expression a lot in the digital electronics. Boolean algebra means the algebra of logic. Algebra of logic is called what? Boolean algebra. So the algebra of logic or Boolean algebra, we use that just to display our logic gates and to use it a lot in a digital electronic system. Now their symbol, Boolean algebra expression for AND gate is a dot or multiplication dot, just a dot. So how we write it? We write it A dot B is equal to C. That means A ANDed input A ANDed to input B to get us output C. So in math we said we can do this thing. 3 times 2 is equal to 6. So this one is equal to 6. Same thing, but we cannot do that with numbers. They will become different, since this is algebra, or this is a simple mathematics, arithmetics here. But we're talking about the Boolean algebra, and we can do that just by writing it in this manners. A dot B is equal to C, or A ended with B, or A input A ended with input B will give us an output of C. We can write it down. A B will give us output of C. Input A and input B will give us an output of C. Okay, so moving on. Hope that's easy. It's not that bad. That's AND gate. You have to have this one, input A and input B both on, to get your output of desired output. You can name it anything you want. In English, we said input A is ANDed with input B to get an output of C. In Boolean expression, we said A dot B, A ended B will give us output of C, or input A ended input B will give an output of C. Or this will be same thing as we wrote it down there. A B equal to C. And as a logic symbol, we talked about that earlier. This is a logic gate for AND. Input A, input B. It will give me input of C. Now the truth table, I'll write it down. I'll draw that table here. So we got one. That's my truth table. Let's make a truth table. Truth table is, I will discuss all the possibilities for your inputs. Input number 1, input A, input, I don't like that. Let's redraw this table again. A little bit bigger so I can see it. Okay. Okay, that's input 1, input 2, and that should be your output. Output, input 1, input 2. Okay, so input 1 and input 2, I can do that since it's a Boolean expression. So input 1, if it is 0 and input 2 is 0, or if it's low, input 1 or input A is low, input B is low, the output will be 0 or low too. Now if you have input 1, let me correct that one. That's 1. Input 1 is high and input 2 is low, your output will be still low. Now if you have your input 1 is low and input 2 high, your output still be low. But in a very common series scenario, if you have input 1 high and input 2 high, your output will be high. So that's the output, that's the representation of a truth table of AND gate. When we talk about gate, we just don't think about Bill Gates or the door gates, anything, but it's just talking about the logic gates here, guys. So there is one note here to remember. The term logic function implies the logical relationship between inputs and outputs. So the logic function implies the logical relationship between inputs and output, while logic gates suggest the physical implementation. So this is a physical part. The logic gates are physical part, but the logic functions are the logical relationship between inputs and outputs. That is a function of a logic function. Now you might have seen it here, like we only use it 2 input here, but you can have a logic gates having more than 2 inputs. For example, you can have 3 inputs, 4 inputs, 5, and any number you can name it. It can have that many inputs to use in your AND gate. So in this logic gate symbol, we see like we have 3 inputs coming in. You have only 1 output going out. You have 3 inputs, AND gate. If you see right here, you have 4 inputs, AND gate. This is 4 input coming. So in this condition, you have to have A, B, C, 3 high, all 3 of them high, in order to get your output high. Truth table for that will be like that. I'll draw it down. So we'll name input A, B, C. In order to have this output on, you should have input A, input B, input C, all 3 on to get your output I call it D here, output D on. So the truth table will be, if input A is low, B is low, C is low, the output will be low. And if input A is high, input B is low, input C is low, output should be still low. It'll be all the way, the output will be low all the way until you get all the inputs higher. So that's the AND gate's definition. You have to have everything to get your output high. Okay, so the same thing will go. Please go and review this truth table, and we will talk about next time. We'll talk about OR gates in the next lecture, to determine how many possibilities you have in the gates, in the Boolean algebra or truth table. You have to do like, you got 3 gate there, you power it up 2 to the 3 will be 8. You have 8 possibilities. From 0 to 7 you have all 3's, 1, 2, 3, 4, 5, 6, 7, 8. 8 possibilities you have. And here you will have a 2 to the 4 will be 16 possibilities. So that will be your truth table, how to determine. So as I said, we'll talk about OR gate next time. Please be careful, and don't forget to subscribe this channel. Thank you.